Okay guys, it's me Imad from Nelson Darwin Park Tech YouTube channel. In this tutorial, we will learn about the Kirchhoff's voltage law implementation within the multisim. As we know that KVL used to say that sum of all the voltages that are rises within the circuit are always equal to the voltage drops within the circuit. Means that if there is a voltage rise within a circuit, it must be equal to the voltage drop, or sum of the voltage rises is equal to the sum of the voltages drop. So either it is true or false. We have to verify it via multisim. So for it, first you need to go to your components and take DC power. Now this is our DC power. Now we need to take certain resistors which will act as the loads, or we can say that they act as the voltage dissipator, but we cannot say the proper word is not dissipation, it must be voltage drop. Okay, so we will go for our resistors. So we will go to basic, we can go for resistor, we can go for 470, we can go for like 287 and like 953. Okay, these are the three resistors. Now we need to connect them like this. Okay, and now we will connect them out. Okay, like this, and so now it is a closed loop. So there are four components. The one is the voltage riser component, and the all others are the voltage dropper, or we can say that they used to drop the voltage. And how much voltage is dropped, for it we have to use some voltmeter. So we will take certain voltmeters for us. Okay, now and one more thing, that we have to sum the voltage drop in order to equalize it to the voltage rises within the circuit. So like this and this, you can arrange them like this. We also need to connect the ground on the bottom because it is necessary. Like it. And these voltmeters must also be connected in parallel because voltage always measured across the component. Okay, and current, if there is current measurement, then it must be through, okay, through the circuit or through the point. But if there are like voltages, then we have to measure them in parallel or parallelly across. So now we need to run it and we will see that it can take a bit time. Okay, now if we use to add all these voltage drops, so 6.688 plus 3.298 roughly gives us around like 9.9, and then 2.014 will gives us like approximately equal to 12. That is 6 plus 3 and plus 2 is 11, and then after the decimals, if you use to add them, they will perfectly gives you 12 volt. So hopefully you got the concept that we have proved all the voltage drops must be equal to the voltage rise within the circuit. So thanks for visiting our channel.